You react the calcium in one beaker with oxygen and the other with sulfur. The reaction with oxygen forms the compound calcium oxide. Okay. A says, what do you predict is the chemical formula for the compound formed from the reaction? Okay, and which compound has more mass? The compound containing calcium and oxygen. Okay, the way you figure this out, it says that if you react it with oxygen, the reaction is going to form calcium oxide. All right. So then the next one says, what happens if you react it with sulfur? Okay, calcium plus sulfur. Okay. Question to think about is, where are oxygen and sulfur on the periodic table? Okay. So if you look at your periodic table, I'll just use this one for example. So oxygen is here, right? You notice sulfur is right below it. Okay. Oxygen and sulfur, the reason that they are in the same vertical group is because they have similar properties, which means they react in similar ways. So oxygen is going to react in a similar way that sulfur does, which means when you add calcium and sulfur together, it just takes one calcium and oxygen to combine to form a compound. So it's the same thing with calcium and sulfur. Okay? Just CaS. Then the next part of that question says, which is going to have more mass? Well, if you look at sulfur versus oxygen on the periodic table, which one of those two things has more mass, oxygen or sulfur? Okay, you should look at your periodic table and figure out, and that's basically going to tell you which one is going to have more mass after the reaction. Okay. Next question I want to take a look at is, well, we'll practice with a couple of these questions. If something asks you to do something like this, okay? If I take NaBr, sodium bromide, solid, and I add water to it, the question is what's going to be produced from that reaction, okay? And the key thing to remember is that when you take a solid and you add water to it, you're just dissolving it in water, okay? So you don't need to add the hydrogen and the oxygen to it. All you need to do is put down aqueous, because this tells you it's this substance dissolved in water. Okay? So you don't have to include the hydrogen and the oxygen in this formula because it's assumed it's there when you put aqueous. Okay? Could also do something like this. What if I have sodium bromide and I want to make sodium bromide liquid? Okay? If I want to take a solid and make it a liquid, do I add water to it? Not necessarily, because that is going to make sodium bromide dissolved in water, which is this. Okay? Aqueous, not pure liquid. So basically, if I want to take this and make it into a liquid, I have to melt it, right? I got to add heat. If I want to change a solid to a liquid, I got to heat it up until the point where it becomes a liquid. I'll do one more example of a problem that you might find on your test review. Okay. Let's say I have something like this. Okay. There's the chemical formula for it. The chemical name for this stuff, you guys already know, it's called baking soda. Okay, baking soda, pretty common substance in the house. So if the question asks you how many different elements are in this formula, all you have to do is look for the capital letters. Okay, here's a capital N. Okay, so there's one element. That one is sodium, right? Because it goes with that lowercase one. So this is sodium. Then I have a capital H, hydrogen. Then I have a capital C, carbon, and a capital O, and that's oxygen. Okay. So the question will probably ask you how many different elements are there. Okay. If I'm just looking for different elements, I've got sodium, hydrogen, carbon, and oxygen. So total different elements would be 4. Okay. If the question asks you how many total atoms do I have, total atoms, it would be 1 sodium atom, 1 hydrogen, 1 carbon, and then 3 oxygens. So 1 plus 1 plus 1, 3 plus 3 more is going to be 6 total atoms. Okay? So those are kind of the main things that I wanted to review. Oh, one more thing. Pairs of elements. So if I have something like, take this periodic table out again. Let's say I ask you a question like, okay, here's silicon, right? Tell me an element that's similar to silicon. What element has similar properties to it? Okay. You might think this one over here. That one is, I believe, aluminum. Yep. You might think this one over here, phosphorus, because they're next to each other. But remember, if we're talking about similar properties, it's got to be things in the same group. So anything in the same group as silicon is going to have properties similar to it. So carbon and germanium, and then this one down here, which is tin. Okay, so these things react in similar ways because they are in the same group, and we'll learn why that is. It does have to do with the number of sticks that's present in each one, and we'll talk about the fact that those are electrons. So those are the main things I wanted you to know for the test review. If you have any questions, email me at my school email, fritbr01. It's right here, FRITBR01 at southredford.net. And I'll do my best to answer those as quickly as I can. Okay? Have a good weekend. We'll see you guys on Monday. Go Eagles this weekend.